name is Michael Fitzgerald, and I'm delighted to share my insights on technical training for sustainability transition. I've been concentrating on the electricity utility sector, which has been my field for 45 years. I'll mention technical training in the Irish Electrical Transmission and Distribution Utility, which is called ESB. I'll describe the European Green and Digital Transition Group and the work that we're doing. I list the key challenges facing us in Europe and the importance of the electrical network in tackling these. I'll look at plans for the electrical network and the challenges in delivering them. I'll review the labour market data that we know for capacity and capability within the professions that are related to the delivery of the network. I'll finish with some observations on what I think would be useful in driving the sustainability agenda. What I'd really like you to take away from this presentation is the key role of the electricity network in achieving the EU strategic goals now and over the years to 2050 and beyond. So to those young engineers and apprentices who may be listening, I'd like to say that this industry is particularly interesting, it's challenging and it's rewarding, and is very much connected to the future of sustainability in Europe. But first, I'll give a brief introduction to myself and my experiences over the years. So I began my career with a science degree, and I was a science teacher for quite a few years, several countries in a number of different educational systems. I then went back to university to take a degree in electrical engineering and a master's, and had my first contact with the electrical utility system as a graduate trainee with South Wales Electricity, as they were at the time. So post-graduation, for the first 2 years in the field, I worked directly as part of a technician cruise on overhead lines, on cable jointing, on substation construction and maintenance, and then on system operations. So this I found was an excellent basis for any engineer who wants to build up the core practical skill sets that undermines the broader academic knowledge of engineering. Then onwards to ESB, the power utility in Ireland, both ESB International and ESB Networks. These were a fantastic place to work for many years, designing, building, project managing network in many countries as engineer and then consultant and later manager and head of departments. I've led the project delivery, asset management, HV design group in ESBI before moving as regional manager to ESB Networks. One of the highlights of the regional manager role was leading the National Storm Response Team, over 2,000 staff, after a series of damaging storms. There, along with new ways of working with helicopters to carry out surveys, we set up contacts with other EU utilities that would prove particularly useful in future storms. At the beginning of my career, I was involved in technical education, then over 30 years of engineering practice. This led me back to my final chosen role as Director of Technical Training in ESB Networks for a number of years until I retired at the end of 2023. So I'll mention the ESB Networks Training Centre, which is a very special place, and I would like to share some of this with you. So ESB Networks has a state-of-the-art technical training centre where all the networks that can be found out on the field are replicated in a training environment. So from actual 400 kV lines to cables, live 38 kV and MV substations, cable test labs, high voltage test labs, and system simulators. The facilities are best in class EU-wide. There are currently over 600 apprentices there, and I'm glad to confirm that 25% of these are now female. This is the highest level of any company in this sector in Ireland. A lot of work has gone into this achievement, which was recognised in a National Diversity Award for the centre recently. Apprentices are trained to level 6 in Ireland, but they have the option to go on to degree level or further, and with modules that are focused on the sustainable design, construction and operation of the network. Some of these modules are delivered in the training centre. ESB Networks also trains engineers and network technicians in all technical skills, and particularly they manage the competence under a competency assurance system to ensure that skills are developed, maintained, tested over many years. And this is obviously critical in such a safety critical environment. So you can see on the list some of the wide variety of training carried out and the flexibilities that this demands of trainers and trainees, as well as electrical skills, core competencies for the technicians and engineers would include driving of 4x4s, which is obviously important in the field, and some of the heavy equipment. Trucks that you use, you can see our new Unimog fleet there in the middle, which are driven in difficult conditions, as well as timber cutting. So for this, we have our own test tracks, our own driving tracks. We have a forest track to make sure that the heavy goods vehicles can be driven in practice in areas where people are likely to encounter difficult conditions in storms. So innovation and digital competence are key to effective learning, and the centre has its own skills that has collaborations with universities in Ireland, as well as with our peer utilities in other EU countries. The centre works with universities to ensure innovation and learning, and I'm glad to see the Atlantic Technical University are very much to the fore in this area. I hope to speak to them later on about this. So over 5 years ago, I foresaw the need for major expansion of the centre to meet increased demand, and I'm delighted that this is now in construction. I'll mention the next area here, which is the European Association for Apprentices, EEFS. So ESB Networks joined this group in 2018. It's a European Commission group which supports the development of apprentices and apprenticeships, and particularly in my case for the green and digital transition. So this has been up and running now for a number of years, as you can see, with the Green and Digital group being set up in 2023. I'm the facilitator of that. Members are from 110. There are 110 members from 24 countries, still growing. The members are from many sectors and represent companies, vocational training institutions, universities, representative bodies, and regional authorities. So the group definition of sustainability, as you can see on the screen, includes action on climate change, biodiversity, and EU competitiveness. So we aim to identify and promote best practices that will deliver these skills, those needed to achieve sustainability. So we recognise that the aims of the green and digital transition also align with mobility of technical staff in the EU. And last week, I was delighted to hold a webinar with the mobility group within the European Commission, where best practice promoting both aims were highlighted. In this case, it happened to be the tourism sector. So this is a type of engagement and cooperation within sectors across EU borders that I think is very important to develop, train, and streamline essential competencies in the sustainability transition. So I will mention some of the critical challenges facing us in Europe here in 2025, just even based on news headlines, which I think are very, very clear and consistent and capture the moment very well. You can see what the challenges are. Climate change and nature loss pose the greatest risk for humanity. And this is according to the World Economic Forum's risk report for 2024. We already know from the EU's Copernicus that the 1.5 degree temperature increase barrier is on track to be exceeded. So a second challenge from across an increasingly unstable geopolitical landscape in the world, that's energy security, also a challenge. We are aware of the reliance on electricity, and we're aware of the dire consequences of even a short-term outage on a large scale, as we have seen recently in Spain and other places. So energy security is particularly important. The third challenge is EU competitiveness, another strategic goal of the EU in a highly competitive world. So effective, less constrained electrical network across the EU can help both energy security and energy costs, thereby improving EU competitiveness directly. So an efficient, competitive EU with a resilient, secure energy system is a very effective contributor to carbon reduction actions needed to tackle the climate change. So what is the electricity network in Europe? So it's the highly complex, as engineers on the webcam will know, it's a highly complex system of overhead lines, cables and substations, along with the communications, control and protection systems that operate it. But through a series of power transformations, the network can move bulk power at 400 kV or sometimes above, down to lower voltages, and eventually to 230 volts domestic level. So for engineers, you'll know that power loss through the heating in lines and cables is based on I squared R. So by reducing the current for the same level of power transfer, by increasing voltage, we can transfer power a great distance with minimum or with reduced load loss through heating. So the network allows the connection of renewable generation, whether that's on offshore wind, onshore wind, solar, wave, tidal, or biomass, and the transport of this power to wherever it's needed by people, industry, and services. So without an effective, reliable network, the core target of installing non-carbon producing renewable generation is made more difficult, if not impossible. Similarly, energy security and price are related to an efficient network, interlinked and backed up across the EU. So to add a touch of brief historical context, an early version at the beginning of the EU was for an early vision was for a common energy policy, and this has proved to be a wise goal in hindsight, though challenging to achieve. At this stage of our journey, it's well recognized that the transition to energy sustainability is directly related to a well-functioning transmission system. So as the president of CIGRE, which is the large energy systems group based in Paris, has said on a number of occasions, there's no transition without transmission. So in line with this recognition of the importance of the electricity network, there are major increases in capacity investment that are planned with a very short delivery window. This investment will be felt in every corner and every area of the EU, and comes as other areas of the world are planning to upgrade their networks similarly. So resources, training and skills in this area are in worldwide demand, and you can see on the screen some of the very large investments that are planned, including here in Ireland, an extra 3.5 billion investment in Ireland's electricity infrastructure. So you can see that this investment is only going to increase in the future, and it will be on a massive scale. So we've established that the vision for the electrical networks is continuity and its expansion, its integration, its interlinking. So there's going to be a very large expansion of the network, but this, of course, brings a number of challenges. So the first challenge in this expansion is that the steady state assumption of an alternating current, thermally powered network with power flows in one direction, this is no longer valid. This assumption is no longer valid. The system of the future will increasingly be a hybrid system with a mix of alternating current with DC interconnectors, with renewable generation of various kinds, and some thermal backup being injected at various points along the grid so that power flows can be in any direction. So this is an increasingly complicated system, and it requires a deep understanding of the physics and the engineering involved and how the various components impact each other across a wide variety of variables, some of which are only becoming known now. So I will mention SEGRE. SEGRE, as I said, are the large power system group based in Paris, who look at research, development, collaboration in the industry, and very much are on target in terms of setting the trends for this area. So what are these technical challenges to this ambitious development of the electrical network? So from a conference, a week-long conference that was held in Norway this year, some of these challenges were discussed among the group of engineers who were there. And I've just picked a number of them here so we can just have a brief look at the complexity and the variety of challenges that exist. So, for example, they highlighted are the increased, as I've mentioned, the increased system complex arrangements that they have. So we have AC and DC connections on systems, operations, and system design. Research needed on that. We have the forecasting of dynamic line ratings, for example, so that traditionally, as some of you will know, cables and lines were run based on summer and winter load ratings, which assume certain variables. But this is no longer the case. They need to be run on thermal line ratings, so you need a real-time indication of how hot those lines are running, or cables, so that they can be run to maximum efficiency. Making more use then of existing networks. So, for example, designing a 400 kV network that can use an existing 110 kV line corridor without needing more planning permissions and delays in terms of building that. Keeping cybersecurity ahead of malevolent actors. is more important than ever as the network digitizes and as society digitizes. So this means IT engineers are very much part of the solution, the skills solution in this area. And then you'll see there, one of the tasks is keeping the public aware and public opinion constantly consulted, so that unnecessary challenges to development of the network are mitigated. And then finally there, I mentioned that respecting ecosystems while building for the future is a very important aspect of this work. So from an education perspective, I'd ask, how are these challenges being addressed? So from here in Ireland, we see that one of our newspapers here, the Irish Times, in an article some weeks ago, mentioned that providing the skills to make Ireland's energy transition happen requires a wide variety of skills, not simply as we would expect, not just engineering, but also project management, IT, data science, many other skills. So it's a widespread various skill base that's needed to deliver this new grid of the future. And if you look at the awareness creation, which is very important and has been mentioned by our presenters earlier on, the creation of an awareness for the need for sustainability education. From our Engineers Ireland website, we see that quite a number of awareness creation type courses are being run at this level for various types of renewable energies, and some of the core data and basics behind that. And obviously there's a great deal of work being done at university level to put longer term degree, masters and further education courses around these, to give these more, to put the flesh on the bones basically of this awareness. So if I can mention what the list that we mentioned a while ago from SEGRE in terms of skills identified. The skills needs, as I've said before, are complex. So we need an intensive focus at higher degree level. Many of the challenges that we have seen here require research first. Before we can train, we need to understand. And as we understand, we need to train the trainers. We need to train the utilities. We need to train the universities. We need to train the manufacturers of equipment. So we need a training plan. So some of these are core engineering challenges that need a great deal of effort before we understand what the solutions, what the best solutions are. So what I'm suggesting here is to have an effective training, we need trainers in place with training tools and resources. So who trains these trainers? Who funds the facilities? It takes several years to set up a training system before any workers appear out of the other end of the pipeline. So all need an enhanced level of engagement between utilities, manufacturers in the sector, and educators. I think each bring their own complementary input, but in my experience, it takes all three in order to have an effective solution. Some skills in this area are not as yet scoped or developed for the sector, and certainly time is burning. I would suggest also that we need a database of skills for the sector and a classification in labour market surveys so that the skills development and scale can be monitored and managed. This is not currently done at a high level. I would suggest perhaps that the European Commission's Pact for Skills database might be used in this way. So I said I'd mention the labour market survey. So if we look at what we currently know, CEDEFOP, which is a European Commission market survey that's carried out every number of years with inputs from a number of sectors, from industry, from educational authorities, etc., and along with a number of other factors, it comes up with the labour market survey of availability and demand. So looking at this, I've looked at the database and for the electricity network for sustainability. And what I find is the last survey, which was based, among other metrics, on market submissions, relates to 2022 figures. And there are obviously caveats in looking at this high-level data, which does not have a specific electrical network category in terms of skills. So the best we can say is that it may provide some trend indicators. So I've taken the return for the past for the four most closely related professions for the electricity network, which are electrical and electronic trades, building trades, science and engineering professionals, and associated professionals. So from the trend, you will see that between 2025 and 2035, the critical years for the sustainability agenda, the trend shows a small increase in availability over the next 10 years to 2035, but only in science and engineering professionals. The other professions are either static or even falling. So this suggests that if this data is to be relied on, that there will be a major skills and resource gap to 2025 in this critical sector. So taking another listed sector, again only indirectly linked with the electricity network. So we see that the market responses here indicate a small increase of about 15% in worker demand to 2025. And this particular sector is the electricity, gas, steam, and air conditioning supply profession, which, as I said, is only indirectly linked with the electricity network. So if these trends are as they appear, this suggests a small increase in availability over the next number of years. So certainly it also suggests that a quantum step change is needed in demand projection within the sector if we're to kick off the dramatic changes needed in capacity and capability for 2035. So moving on to the development of these professionals at university level then. So where's that at? So looking back into our pipeline, further back to educator and trainer availability and demand, this is what we can see. So a small increase in this survey in teaching professionals at higher level will be available by 2035, up 5% on the 2025 level, but with a drop in other levels of teacher. The sector indicated in 2022, when this survey was taken, that there was a sufficient need, pretty much a sufficient need to meet the anticipated 2035 demand. So when the professions and the institutions were asked to project to demand, we can see that there will be a natural increase of a small increase of about 5% over the 10 years in availability. But the professions who responded to this survey suggested that that would pretty much be enough to meet the demand of teaching and training the professionals needed to deliver the electricity network. So again, with caveats, it would suggest that there is very limited resource planning for having trainers to train future trainers. let alone train workers for the future. And again, time is ticking. And I suggest and I stress that these are surveys based on data from 2022, which was proposed, and I would suggest also that the most recent figures from 2025, which will be available next year, may give different and hopefully a stronger market indicator of where demand is going to be met by having more trainers, more research, and more young engineers and workers in the various sectors that we need for this critical area. So if I could summarize my conclusions then, the electrical network is essential to achievement of climate targets, energy security, and overall competitiveness in the EU. There is an ambitious programme for investment in the network to achieve these strategic goals. There are also challenges to building and operating a more complex hybrid system that need committed and focused research now. Current skills need to be enhanced and new skills identified now for 5 years' time. Current labour market projections, while unclear from the database, suggest a reset is needed to match investment ambition. Importation of capacity and capability is not a viable alternative. The shortages in this sector in terms of skills, capacity and capability are worldwide. All of this requires a close working relationship, and I stress this would be between utilities, manufacturers and educators to research solutions, to scope skill sets, to train trainers, to build resources and to train trainees. And the pan-EU collaborative effort is most likely to be effective if implemented with ambition. And finally, an opinion which based on my 45 years of experience in this industry, I think would be a useful addition to boost the efficiency of training and competence development across a number of sectors that lead to the infrastructure developments that we need. The barriers to setting an effective and efficient training map for the electrical network sector, barriers are well known and they seem impenetrable. However, I think the rewards for standardized, recognized core competencies are, I believe, self-explanatory. So as we see, there are many models of apprentice training, many models for engineer training, many regulatory regimes, all different. Recognition of training is not standard across the EU, whether it's for engineering or for apprenticeships. There are many, many benefits, as I've listed there, for core standardization. It doesn't mean a one-size-fits-all, obviously, but a core standardization would bring benefits of recognition of skill sets. It'll also have a benefit, I think, in terms of sharing training resources, effective mobility of trainers and trainees from across the EU, more rapid storm and emergency response. The list is long. The question is, can this be done? So as a proud utility engineer and European, I'd like to think that it could. So finally, I was looking at LinkedIn last night, and by chance or by design, whichever, I see this post that came up from one of our members of the European Parliament, Sean Kelly, expressing his view that a cross-border energy grid is important to undermine our green energy transition, which I was delighted to agree with him on, saying that in my view, It achieves the targets, or would help to achieve the targets for sustainability, energy security, and EU competitiveness. And with that, I will say, Margaret, obrigado, merci, thank you, and gracias.